So now we're going on to machines now. So machines are multi-membered assemblages, but where the members can move or transmit forces. And one of the simplest machines is a pulley. And so you have to be able to deal with pulley problems. Pulley problems show up on statics tests, they're on dynamics tests, things like that. So let's just work an example. So here's a pulley example. I have a 120-pound load being lifted by this pulley system that's in a vertical plane. And some assumptions we always make in our basic mechanics classes for pulleys is we assume that the pulleys themselves are massless and frictionless. And we assume that the cables are massless. And so the consequences of these assumptions are that once you have a cable, that cable has the same tension in it everywhere. And so one of the first steps you want to do on a given pulley problem is count the cables. And you might look at this and say, well, there's one cable there, there's one cable. You would say, well, there's 4 cables, this guy, this guy, this guy, this guy. But that's not true. This is just a single cable. And so you got a free end of the cable. He comes around this pulley, down here, around this guy, up here, and then down, and then he's tied off right here. So this guy's all one cable. And because of our assumptions, there is a one tension in this cable everywhere. So P here is equal to T, T, and T. And so we want to find that tension, or that P. So what you do, start at the end where you're given a weight or something, cut these cables, and find these internal forces. Remember, cutting something or sectioning something exposes forces. And so the method of sections or cutting something to see internal forces is a critical step. And ultimately, you can argue that this problem as drawn is not solvable. But once you draw a free body diagram, you create a solvable problem. We'll come back to that theme. So if you cut that here, there's 3 cables that I cut. This guy, and this guy. It's all the same cable, so they all have the same tension. And there's the 120-pound force hacking down. Now, I will note that, again, if you've got friction in these pulleys, or if you've got mass in these pulleys, then the tensions are going to vary in these different cables. So these are critical assumptions. But with our assumptions, these are all the same. So if you just sum forces in the y direction for just this pulley, you get 3T minus 120 is equal to 0. And so the tension is equal to 40 pounds. So 40, 40, and 40 equal 120. And so everywhere where you see this cable is 40 pounds, 40 pounds, 40 pounds, and this P is 40. And so that's the tension in that cable. When you get to dynamics, we'll work dynamics problems with cables too, and kinematics problems with cables. But for now, we're just dealing with static forces in the cable. So this is a 1 cable problem. Here's a 2 cable problem. And so I've got a pulley here, a pulley here, a pulley here, A, B, C. I have 1 cable that comes down around this guy and comes up, it's tied off on B. I have a second cable that comes down here around B, up around A, and then down to this free end here at P. And this system is holding up a 400 Newton load. Massless, frictionless pulleys, massless cable. So how do I solve this guy? Well, I have to start at the load, which I know. And so if I cut him here, this lower pulley here, this is cable 1. So I have a T1 and a T1 and a 400 down. Sum forces in the vertical direction, T1 is equal to 200 newtons. Once you get T1 is equal to 200, now we can go up to pulley B and draw a free body diagram of him. And of him, you get T2, T2, which is the tension in cable 2. And then you get T1 acting down, which we just found to be 200. And so if you sum forces in the vertical direction, you get T2 is equal to 100 Newton. And once I get 100 in this cable, the pulley A just changes the direction of cable 2. So P here is also equal to 100 for T2. There's actually such thing as a 3-cable or 4-cable problem. Actually, we can sketch that too. So this is a 3-cable problem where you basically have a lower pulley here that comes up here. This is a 3 cables. So there's a cable 1 that comes down here. There's a cable 2 that comes down here. Cable 3 that comes down here. All 3 of these cables each have their own tension. So if you draw a free body diagram here, the cable T1 is half of 300, which is 150. Take the second free body here. You've got 150 here, and then 2 cables up. So T2 is half of 150, which is 75. Then draw a free body diagram, the diagram of the third pulley. You get 75 down, divided by 2. And so this is 37.5. So your T3 is 37.5, just by inspecting the different free body diagrams. So these are classic pulley problems. It's probably one of the simpler machines you may or may not have on your test, but they show up. They look hard, but they're actually really easy.